Olá a todos, sejam bem-vindos à terceira DevTalk. Finalmente vamos ter a terceira DevTalk. Pedimos desculpa por este atraso inicial, mas já aqui temos o homem do momento para nos dar aqui uma aula fixe a todos. Sean, vem daí.
Olá, boa tarde. Obrigado por estarem a ver a talk. Peço desculpa a todos que estavam cá a semana passada por não ter aparecido. Infelizmente, a minha noite não foi assim tão agradável em termos de trabalho. Hoje o tópico que vamos falar é mais à volta de como olhar para entre escolher um Monolith ou um Service-Oriented Architecture e tentar ter uma perspectiva sem bias em que possam escolher aquilo que vai funcionar melhor com o vosso projeto ou com o objetivo que têm em mente. Para começar, em vez de estarmos antes de entrarmos mais em opiniões, vamos só tirar o glossário do caminho. O que é um monolito? O monolito é o conceito mais tradicional. Basicamente, tu tens a tua aplicação como uma unidade singular que depois fala com dependências, que no caso normal de uma aplicação de web seria ou o cliente, ou a base de dados, ou um servidor de search, ou alguma alternativa assim, mas o parte em que vocês escrevem código e criam da aplicação é uma unidade única, independentemente se tem a ver com base de dados ou entregar um bocado de front-end. Isto é a maneira, quase sempre foi feito assim. I forgot to ask, can I speak in English?
Yes.
Okay. All right. It's a more traditional concept, and it's much more common and easy to do, and that's why it's still something that people are adopting and preferring over the new and cooler oriented architecture. It's simpler in concept because you can test, you can deploy, you can have a staging environment, because you have very simple stack of applications. So you don't depend on any transport layer. Everything talks within the same machine. And it literally allows you to write an end-to-end test without having to depend on any kind of network layer. It has a very simpler in-concept scaling. If you need more hardware, you add more machines. If you need more throughput, you add more instances of the software in each machine. So it makes it very easy to think, oh, I just need to add more. But because of that, then we start going into the bad sides of the monolithic architecture, which is the more you add more, the more the complexity scales over time. You end up in the end having, a gigantic piece of hardware because of one part of your code that is slow, and the rest of your application uses less than 1% of that, which, in an ideal scenario, you would be able to scale that in such a way that the part that takes a lot of hardware is running on its own specific hardware. But because you have everything as a single unit, you stop having that option. As for the developer experience, it's probably the worst because everything you touch in the code is going to propagate to everywhere. So you're going to have a lot of strain in your QA team and your tests because everything you do literally needs to be an end-to-end test. You cannot rely on particular unit tests or smaller integration tests. Usually you see a monolith being paired with a strong QA team and probably something reliant on Selenium for a more manual, like click the button, does the thing that I want approach. The last part of it is that if you have a bug, it affects the whole stack. There's not separation of concerns. So if the part code that you wrote that talks to the database for some reason is unperformant or not doing a transaction well, the cost of memory that has is going to impact adversely every other part of your application. Might be as unrelated as filling out a template, which just wants some CPU time. Now we have an idea what the monolith is. Let's look at the counterpart, the service-oriented architecture. And basically what this is grabbing each of the concerns of your monolith and putting it on it's a very tiny monolith of its own that only does that thing, and then you kind of take a factorial approach to it where you just grab the same unit, repeat it, and you do that for every business vertical that you have. An example of this would be if you have a database, instead of all of the units of your application talking to the database, you have a app that runs on top of the database that provides an API, either be by a messaging layer or HTTP layer, that provides all of the access within that API. So you don't have any other service connecting directly to the API, only the one that serves the database stuff. Now, this sounds like very new and cool, and everyone likes smaller units, but it's very complex to start because you need to look at what you want to do. If you want to put a piece of text on a website, you're going to need a service that manages your database, that exposes an internal API to reach every table, non-SQL part of your database. You're going to need a part that prints the actual text. You're going to need a part that computes what text goes in there. And finally, you need your client-side application. So to start, imagine if you just want to put a website saying, this is my phone number, call me. It might not be a great idea to go with a bunch of services. You have forever cost of systematic bootstrap. Bootstrap is, hey, I have an idea, let's make something new. Here's like the stuff that we need for us developers to work. With service-oriented architecture, every time you instantiate a new service, you're gonna have a bootstrap cost. This might sound simple. Everyone, started a project before, and it's usually the only part that gets done before it goes into the closet of never-ending projects. But that part, over time, ends up being time that you spend the most with your engineering team. The best part of it, though, is that you finally got that neat separation of concerns. If your search team says, we're going to do a whole new search, they just build a new service that does the whole new search without touching the existing one, and when the time comes, they replace them. You no longer have to deal with feature flags, swapping different parts of environment variables to hide, non-hide parts of the undeveloped application. Now, that all sounds amazing, but then this comes at a huge cost, especially running-wise. Every day, you are dealing with a network layer or some sort of messaging transport, which, while standardizing error handling, is still error handling. You can never guarantee the delivery of a network request, so you need to have all these retries. Retries means that you have to have exponential backout. Exponential backout, that means that at one point you need to say, I need to reject service so that I don't impact the rest of the application. So all of the usual concerns that you have that usually just exist between your API or your client application and the UI now exists in between every little component of your application. Now, the second part of this is that everything's asynchronous. Even if you go with a messaging system with a guarantee of delivery, you don't know when that delivery happens. And that, as simple as it sounds, I've heard people say, oh, it's easy, every system just has a queue. But then you have, a queue on system A is building Y because the queue on system C built, oh, why? And then you're just following queues until you reach the top of the problem. So asynchronous complexity is a thing, and if you're a JavaScript developer, you felt it in pain several times. Now, like I said earlier, the final, most negative aspect of service architecture is it's really costly. If you're, a developer with a dream of a startup and you're going to get started and you have, $1,000 in the bank to make it happen, service-oriented architectures are going to be, even, if you go with a very microservices approach, it's going to be outrageously expensive. So what is the point of looking at these two things and bringing it up as a discussion? Recently, I've heard everyone saying that there's no other way. Service architecture is the way to go forward, is the modern version. Anyone that's doing otherwise is, stuck in the ages, as some old developer with a mustache that thinks he knows better. I want to make an argument and try and introduce my bias because I do have my own formed opinion, but that opinion is based on goals, and how I choose to use each one of the approaches is what I really want to share with you guys today. Is it a replacement? No, it's not a replacement, except, because I just gave you an example. If I'm a developer with a dream of making a little thing, I'm not going to go and start developing each service in the stack to finally get to my product. So team size is the first factor that I take in when I'm going to choose which one to go for. Why does team size matter? Because if you have a team like I do now, that it's me and 3 other developers, it would be insane for us to try this, because all of my time as the senior engineer would be developing the service structure, and then try to code all of the bits that go into that structure. And basically, we would go 1 to 2 years without delivering a single product feature, which, if any of you have done any startup work, you know that that's a dead startup. If you don't release for a year, you're gone. Someone else is doing it better than you. Now, if you have a large team full of senior engineers all ready to work, by all means, grab each one of those seniors, give them one a concern, have them all build everything in parallel. It's going to work great. Second factor that comes to mind when choosing which one of these is time to market. If you got the next killer idea and you need to do it before anyone else does, you're not even thinking architecture. If you can fake it, like you don't even think, I need this fancy server logic or search logic. No, just make something that looks like it, and then when the investors give you money, you do it the correct way, and you take all of the other factors that I'm going to talk about here, and you make your right decision. But at the start, you're not going to think of services. You're going to do the quickest, simplest step to get there. So most likely a monolith with everything piled up and full of bugs. Okay. In the same spirit, time to market is the cost. We rewind a little bit back to the part where we mentioned, if you have $1,000 to make a company happen, you need to think it costs wisely. If you go to a service architecture, you're going to have a hardware cost for each one of the services, and eventually, that's the cheapest you can be. You can have the cheapest version of every service, but that's the cheapest your application will ever be. A monolith, hell, you can run it from your home computer and not spend a single money in the server until you actually have to. So, cost-wise, you're probably better off with going to monolith, but this comes with a little asterisk. Cost only matters until you've got either a profitable business or a solidified source of investment. At that point, and this is why you hear about the term MVP in startups so much, is that you build an MVP and you shouldn't take it for your next level. You should take the lessons you picked up from there, maybe a few parts of the code that you consider valuable or that have been iterated over from customer feedback that you want to preserve, but most of it, it's the most valuable product just so that it's the valuable part. It's not everything else, the dependency hell that you created there. So once you secure that cost that is no longer a factor in your choice, remake the choice. Look back at the other factors, think about it very carefully, remake the choice again. I guarantee you, trying to build on top of a monolith when you needed something more composed will cost you in the long run a lot more than the little servers will cost in the beginning. Now, next step is, how experienced is your team? I'm in a currently very awkward situation where the other two senior engineers have moved on to engineering management, and I'm the only senior engineer for 3 juniors. I am very glad that I have a monolith right now because I don't have to explain the complexities of network layer and why they can't just say request send and it works, why a try catch is required, and it's easy for me. But as we grow in a product, I know that eventually we will have to move to a more expensive approach, mostly because of our search. Our search is this super complex piece of our product that leaves shoved into like a little view in our API, and it's literally a growing cancer in our code that needs to go off to somewhere else. The problem is I'm the only person who's deemed experienced enough by my product managers to do that task, and I'm always busy with something else. So team expertise matters a lot for when you need to make the decision in the first place or when you need to evaluate your decision later on, like we are now. Now, finally, developer experience. It's very cush and nice to work on a monolith, especially if you're in a small team, especially if you're the only senior in the team. You can just ignore the feedback from everyone else and do whatever you want. Don't do that. I'm joking. You work with your team and you have a very concise, but the one problem that comes with that is that monoliths are usually grown over time, and there's a lot of tribal knowledge, which that knowledge ends up getting into the hands of the people who seek it. Doesn't matter how good you have been writing documents, they're no good if the new engineers don't read them. So one big part of working with a monolith is ensuring that developers have a good experience. And that means you need to have a bootstrapped test suite, code practices, linting, all of those things that we take for granted. It needs to be there, and it allows you to have a clean code base. But if it's a monolith with several concerns, a team that works on search might not want the same code quality as the team that works with database access or the guys that work with payments. So at this point, your monolith is now the bottleneck, and you're going to spend most of your time reiterating over tooling, creating tooling exceptions or software that handles your internal problems around tooling. So thinking for developer experience, most of the times the service architecture is going to be the best option, unless you are with like the original team who built the monolith from the beginning. They have all of those tribal knowledges well set and ingrained in their mind because they wrote most of it. Finally is the complexity over time. So complexity over time, it's not really a factor that can be measured, or I guess you can just by the delay included like in your overall request times, but it's very visible to see if you worked with one or the other architecture, or if you work with both, that monoliths are going to become more and more complex and services become less and less complex. The initial setup of service usually becomes the most complex part. Setting up the tooling, all of the developer experience around it, creating expectations, test layer, all of those things need to be set up. But once you have those things, then you're only working on business logic. You never lose your focus from business logic. You never have to go think about someone else. You need to update a dependency of that own service. You can update it. It doesn't affect that old payment system that relies on the outdated version of the thing you want to use the new one. So with that in mind, the complexity becoming simpler is a big attractive part if you can afford to buy in the beginning. Aside from that, you have the sorry, where's my drink? On the monolith side, your complexity keeps becoming more and more complex. So imagine that at one point, your sales guy depends really heavily on a library that's out of date, and the rest of the team wants to upgrade, but you can't because the payment guys really need that version, and they're too busy doing other stuff, so they can't upgrade the version. Now you have an increasing complexity because maybe one part of your application is going to use version XX of this library, but the other guys on the other side of the building are using 3 versions forward, and you're dealing with, dependency hell and finding all kinds of custom solutions to manage those dependencies. So overall, you have a bunch of metrics on how to look of which one will fit your goals. And I'm just going to go into like a small of a rant, basically closing thoughts. And this is the part that, if you own the system and you know how you make your decision, don't listen anymore. You got what you needed from this talk. Now it's just me talking out of experience. I got the pleasure of working with service architectures, many monoliths, and in the end, I build up this list, but I gotta be honest, I never follow this list because I've never been to a job where I got to pick these things. I always get there and there's something built or something already going. So you kind of just go with the flow. Imagine being the guy that walks up to a company that has all services and said, guys, we should use a monolith because, we don't have a big team, and that's never accepted. So you need to think of this as almost a way to evaluate where you're going, right? If you are interviewing with a startup and they have 5 team members and they say, oh yeah, we got a service-oriented architecture, we're super futuristic, all good. What you're gonna hear is they don't have enough resources to complete the project. If you go to a big team and they say, we have a massive monolith full of tribal knowledge, you're gonna learn so much from reading that code. They're struggling with legacy code. They can't update anything. So in the end, none of these is gonna be like, oh yeah, this is the one, this is the future. At least we haven't had a change in architecture that's really that impactful. But now at least you have all of the weapons and tools that you need to choose the one that's right for your project, even if the project's already been chosen and you're just interviewed to work with it. Now, I had a big part of this was just questions, Q&A. I don't know if we want to read some out from the chat. I don't know how to tell how many people are there.
I always have some opinions. I always have some opinions and questions of my own, and currently I'm on this journey of trying to bootstrap a couple of projects that are using microservices architectures, and I'm going through a lot of the struggles you mentioned, but because I haven't been to a position of actually taking care of a production system which is already using microservices architecture, I think I'm still not fully aware of all the consequences, but I've definitely experienced the hassle of dealing with a lot of complexity, and you've mentioned quite a few of the downsides that I perceived.
Was there anyone that you expected me to talk about that I didn't?
Yeah, perhaps there's one or 2 points that I can get your opinion on. So one of the things that I realized and about microservices architecture is that the way you think about your data and how you structure everything is completely different, because you want each service to be fully independent and isolated and decoupled from everything
establishing
else.
contracts between services.
Yeah, and you want to be able to just bring a service down, and everything else needs to work the same way. So you just want to impact that part that you put down, right? And because of this requirement, you really need to make sure that every service has everything it needs to operate properly, and you're not creating dependencies amongst
that's the big thing. I'm going to make an edit to this
services,
talk, because I do now realize that I talked nothing about like failure conditions and single points of failure. That's great insight. Thank you.
Otherwise, you end up with what in literature is mentioned as a distributed monolith, right? So you have everything separated in many pieces, but all the pieces depend on each other, and in the end,
you have nothing that you thought about.
Yeah, exactly.
That's really nice feedback.
But because I'm trying to strictly go by this rule of complete independency and amongst services, it required me to change completely the way I think about the data, where to persist data, where to get copies of the data. What
do you prefer?
Which what?
Transport layer. Are you using HTTP APIs, a RabbitMQ system?
No, I'm using some sort of messaging queue. Depending on, I'm currently doing this on 2 simultaneous projects, and each one uses its own version of the architecture. But we're using an asynchronous messaging queue, and each service has its own persistence layer, the one that it's optimal for that service goals. We need to be really careful about only having one source of truth with regards to state, but then we have a lot of read-only copies, which are like projections of our
like
state,
buffer states
in other services to make sure that they can operate autonomously. So the level of complexity just goes through the roof. But of course, the geek and nerd part of me loves it, because I'm learning a lot of new things, and it's really cool. But I also don't have a big development team like yourself. And the fact of the matter is that one of the projects that we are developing, it's already been worked on for quite a few months. And the first MVP deployment has not been made yet. And the other one, it's also still far from reaching that goal, and already counts with several months of work. So I relate to that part. So basically, these were my comments.
At any point you go, oh man, I should have made this a monolith, so I'll be done with it.
Well, it's that part is true. I should have made a monolith and I would be done with it. But the part that I'm learning a lot, I cannot get it over my head. So because I don't have really strict deadlines on these projects right now, and one of them is kind of an internal project, the other is a customer project, but the customer was the one taking the decision of going with this architecture. So I'm kind of relaxed with regards to that. But
Sure.
if I had a hard-pressing deadline, if I really needed, as you said, to put something out before somebody else does it, then my choice would probably be completely different.
Okay. But the real thing that's going to scratch your head in the end is like, where does the client fit on this? Because both of these service-oriented architecture or monoliths rely on some sort of client, either it be a mobile app, a browser app, something. Is that part of the monolith, or does that make every monolith a service architecture?
Well, what I also realized that I wasn't expecting is that the microservices architecture also makes me rethink the way in which my user interfaces interact.
Absolutely.
Because now everything is asynchronous. So every time the user does some sort of request, presses a button, does something, I cannot assume a synchronous response because
I bet your UI uses a lot of promise.all to resolve them all and finally found a consistent truth.
So the new architecture leaks all the way into the user interface, and I totally did not saw that coming.
I got a question. Did you associate types with your data in the messaging system, or
No, not really. I'm doing it all in JavaScript. I'm not even using a type system on top of it.
Makes
And
sense.
I try to use as much defensive coding techniques as I am aware of, but no, I'm not like strongly typing the messaging system. No.
Wow.
Well, but that's me. I don't know if there's.
There's one question.
Yeah.
You can read it out loud.
Okay. Where can I see it?
How many years of development experience?
It's under your belt.
Oh, I am. So 2006 until now.
Okay.
2006 until now. So 14, 15,
Okay.
17, 16, 15. I don't know. A lot of years. old enough to think of retirement. Any proud projects that you participated in? I hold a patent of predictive search along with the team that I worked with at the time in Google. That's really solid. I don't think I'll ever surpass that achievement.
What else?
No, it did not click for me like at all in the beginning. And I went the whole full developer experience of like, nah, I don't write tests. I know what I'm doing. To I do unit test development nowadays. Like, there's not a single code that I write that I don't write the test that I expect it to fail a million times until I actually get to it. So unit testing, the best way advice that I have for you is smaller bits as possible. If you're writing a function that adds two numbers together, create a test that adds every single digit from 0 to 100 to test it out. Like, there's no exaggeration in testing, and the more coverage you create from the beginning, the more complete your development work will be. Monolith or microservices. If I'm building something for myself, it will definitely be a monolith until I get someone else's investment. But if I'm going to go for work for someone else, then I will just do whatever they have in place. So centralized documentation can help. Absolutely. We currently on my job, we have the fuck up sheet. Sorry for the language. I didn't ask if I could swear. But it's just every time that you mess up, that's kind of where you go and write your little post-mortem about what went wrong, why did it go wrong, what did you learn from it. But it's basically a centralized place to say, hey, this didn't go well, or our goals failed as a team here, and this is why I think it happened. Advice for a junior program: read manuals, read blogs, attention to detail. You're never going to be a good developer if you don't pay attention to the little details, and no, that comes to just reading a lot. The Pragmatic Programmer is a really awesome book that I always recommend for recommended reads. And then anything that the community around your language of choice is promoting. One note about the Clean Code by our dear Martin Robert. clean code's a great idea and concept, but when you work in the professional world, you're going to have to make sacrifices. And I've never been in a single place that fully commits to a clean code because, yeah, you have sacrifices. Instead of reading clean code, make sure that you have a good formatter and linter for the language that you're writing in, and your whole team agrees with the rules that you're applying to that formatter and linter. You're going to get the same result, and you don't have to read that book.
Well, first of all, thanks a lot for your words. I fully subscribe everything you said.
Thank you.
A lot of times you see like fancy people saying that you should go for all these microservices, and my guess is they don't have experience in the real world. So thanks for that. Very cool to have experienced people saying it's not a replacement. And then my question was, have you ever been to the moment where you have the monolith and you need to move because of all those moments you said about, okay, team complexity, experience. So, okay, now you made a decision though. Now it's time to start moving away. So can you talk a little bit about how would you do that?
So I had two experiences like that. At Red Beacon in 2014, we were a full-on monolith, and the company decision was like, nope, monoliths are over. Everything is done in new services now. And he grabbed 6 of us more senior engineers, and they were like, go for it. You guys got 6 months, and while the rest of the team does other stuff to make it happen. And it was an amazing experience. The process that we took is still one of the ones that I think is the best. We developed a very complex end-to-end testing harness. And then we used feature flags.
Sorry, please don't forget the UI challenges that he mentioned.
Yeah.
Because it's not only about changing the backend, right? It goes up to the UI, and it's going to impact everything.
So this UI harness was mostly just Selenium and like virtualized clicking, right? And the test harness guaranteed that what the user received was the same thing in the end. And then we used feature flags to disable chunks of the monolith, right? You know, something, part of the monolith that handled just one feature, move that to its own service. And then at that point, you evaluate the contract, right? Piece by piece. Piece by piece, right? So you take, let's say we had an area of our product that was just payments. All they had to do was talk to Stripe. And they had a UI component, counterpart, that always showed up in its own window. It was, for a monolith, very already kind of separated. So it was our first candidate because it looked like a juicy one to catch, right? And built the test harness for that feature. Everything that the user expects was outlined in that testing suite. Then we are free to evaluate the data contracts, right? With the feature flag, we were able to also change the UI. Right? And unless we told that this feature was the dash service one, even the UI had the old UI unchanged. So that's how we were able to just take one whole vertical of our product, pull it to the side, develop it as a single standalone pillar, and then be able to toggle on and off with a feature flag. So that was the approach. And then I have the failed approach, which I saw at a more recent job. I won't say the name because I don't want to embarrass anyone. But basically, the approach was just like, shut it down. This thing is now a service. Everything else gets built new. So they took the monolith as is without any concerns about how the data transport changes or the data requirement changes or how the relationship between front end and back end for front end type of relationship changes. And what you ended up in the middle was like a spaghetti monster, a Cthulhu-like thing with a very big body in the middle and a bunch of little wings. And yeah, it did not go very well. So if I have like a silver bullet for you to survive the transition, feature flags and extremely comprehensive testing.
And what about the UI?
The UI goes with
because
the feature
UI
flags.
needs to change, right?
Yeah, but it goes with the feature flags. Your feature flag, it should have like 2 states: old version, new version. If it's new version, it's new version for everything. It completely puts the old version out of use. But until you can do that, you can just keep it off and just turn it on for when you need to test, iterate over it, but it won't hold back your release cycle.
Now we have a question from Fabio Martins regarding a monolith versus microservices. Did you find major differences between service response time? If you were working in a project that had different clients, iOS, Android web apps, and also did a lot of communication to other outside services through REST APIs, do you see advantages in going with microservices architecture? I'm saying like a project that would have some persistence in itself, but also communicating with an external service to have on-the-fly updated information.
So, can't really tell you like pick one or the other. You won't find that much of a difference in response times in service-oriented architecture versus a monolith, because the internet's pretty fast. I know like we all like to complain about lag and stuff like that, but when you're running a system that's very optimized for failure and to talking to each other, as you should in a service-oriented architecture, and you'll find that there's not as much lag, because lag usually comes from a server failing unexpectedly, or bad error handling, or queuing times because it's taking too long to compute something. It's usually not the web's fault. So I don't think you need to really concern, like that shouldn't be a metric when you decide for one or the other. What should be in your head, you screaming and yelling when you think in that perspective, is error rate. If one internal service has a high error rate talking with another internal service, that's going to cause severe impact everywhere else in the architecture as a whole. So your services need to be failed gracefully, and it's the biggest requirement not to have a slow or laggy application. Different clients. Honestly, I don't like. You could have your monolith that then talks with all of the other third-party dependencies and has a single channel of communication with your clients. Maybe you have like a client API that just gives massage data from other services, or just a section of your monolith that just talks directly to the API and manipulates the data so that it fits your iOS client, your Android client. But in the end, as developer thinking about not repeating yourself and keeping it very simple, you should probably just have something in the ways of like a user or UI API, which is part of your API that just manipulates data so the clients get it exactly like they expected, so that the UI feels nice and snappy and people aren't feeling like their clicks are slow because you're computing a list of 10,000 schools to show the right data or whatever. So just have an API that has all the data prepared, probably something very cached, like every data that you send to a client that is not critical, but that would probably be my recommendation there.
Anything else? Sorry, we have a question here. This is from Karolis. I struggle to look at code that stinks. How do you control yourself not to refactor the whole method service project while just working on a change column name ticket? Or maybe that's just a me problem.
It's absolutely not a you problem. I think every developer suffers from this at some point. That's why that question is probably the biggest reason I recommend the Pragmatic Developer book, because the best way to do it, and the way that I keep myself from refactoring everything that I see, is touching code's a liability. There's something called git blame, and if you mess something up, it will absolutely come back to you. So whenever you develop something, change the least amount of code that you can. Like think about it, like every little piece of code that you touch might be a reason why you stay up late or miss a talk like I did last Thursday.
Does anyone has any more questions? I guess this is it.
All right. Thank you, everyone, for the questions and for sitting here and listening to me to ramble. If you're a senior engineer and you're looking for a new challenge, please contact Sean at hirenimble.com. We're always looking for new talent.
Or talk to me and I'll put you in contact with Sean. Yeah? Thank you so much for having us and for coming.
Thank you.
It was a pleasure. Vemos brevemente, teremos mais novidades sobre a próxima talk. Um abraço a todos e obrigado. Sean, obrigado.